Okay, for this question, this is question 3E, and again, it's a question we haven't really seen a lot of. We've got a curve that has a gradient function, 3x squared plus px, so we basically have a gradient function that's a positive parabola, so we know that we're going to be working on an equation that is basically a positive cubic. So that's going to be our y, and this is our dy over dx. And the curve passes through points. It passes through -1 and -7, and 2 and 44. So this graph is going to be a little tricky to show points like that. But -1 and -7 would, I don't know, might be somewhere here. And 2 and 44 might be somewhere over here. But anyway, it passes through those 2 points, and we have to find the equation for that function. So we have to go about working our way backwards. Again, we're going to have to integrate, and when we integrate this, we're going to get y is equal to x3 minus, and we've got that px, so we don't know what that p is. That's going to present some additional issues. And then, but we know it's going to be that. Remember, any constant there, you don't differentiate or do anything with that. It just stays the same, plus c. So we're going to have to find out what c is, and we're going to have to plug in a value. That's just what we normally do. We just plug in some point, and it doesn't matter what point you put in. You could put in 2 and 44, but I'm going to use -1 and -7. The problem is that you'll see right away that once you do this, you end up having a bit of an issue, because if I put in that point into this particular equation, and try to find what it is, I end up getting this. So you work it out. If you put in -7 for y and -1 for x, it simplifies into this, which presents me with a problem, because now I've got 2 unknowns. Well, two unknowns. When you see something that has 2 unknowns, really the only way you have to solve it is to use simultaneous equations. Because we've got to eliminate one of those variables so we can solve for either p or c, whatever you want to do it first. Now, this can be done because we've plugged in this point into the equation, but we've also got another point that we can plug in. So we can plug in the 2 and the 44. And what we're going to end up having at that point then is 2 expressions. So let's take a look at what that looks like. So we have this -6 is equal to p over 2 plus c. That's from putting in -1 and -7. And now we're going to need to put in the 2 and the 44. And we'll plug that in to the equation, and we'll end up getting 44 is equal to 8 plus 2p plus c, and then we go about solving that. We get 36 is equal to 2p plus c, and there we go. We've got another expression. Now, what do we do now? Well, we've got 2 things that we can do. We can rearrange this, one of these equations, so that we can substitute in and solve. We can do it like this if you want. We could put one underneath the other, but I'm just going to rearrange one of these and maybe make this one c equals. So if c equals -p over 2 minus 6, now what I can do is I can substitute that into here, because that's one of the ways you do simultaneous equations. It's through substitution. There it is. That's substituted in. And now I solve that, and I simplify it. And what happens is I'm going to end up being able to solve for p, and p is 28. Well, p is 28 means that I can now put that in for the equation. So now that I've found out what p is, I can now stick p in, which is 28, and I can solve for c, because now I've only got one variable to deal with, and I can stick in now a point, and again, it doesn't matter what point you stick in, but I'm just going to go back and stick in -1 and -7 into this, and then I can get c. So I'm going to get -7 is equal to -1 cubed plus 28 times -1 squared all over 2 plus c. Work that out, you're going to get c is -20. So now I've got the equation. The equation is y is equal to x cubed plus 14x squared minus 20. There's the answer to the question.